Have you ever sat around a campfire, mesmerized by the dancing flames? Fire has captivated us for thousands of years. From birthday candles to bonfires, its warmth and light draw us together. Our ancestors relied on fire for survival, warmth, protection, and food. Today, we gather around it for comfort and connection, tapping into that ancient bond. When you watch a bonfire, you're witnessing a scientific marvel that's fascinated humanity for ages. But what's really happening in those glowing flames? Let's uncover the science behind the bonfire's magic. So, what's actually burning in a bonfire? When you gather around a crackling fire, it might seem like the flames are simply eating away at the wood, but there's a fascinating science happening right before your eyes. It's not just the wood itself that's burning, it's actually the invisible gases released from the wood as it heats up. When wood is exposed to intense heat, it starts to break down and release a mix of gases and vapors, which are what really catch fire. This breakdown happens through a process called pyrolysis. As the wood heats, it doesn't just turn to ash. Instead, it transforms, charring and splitting apart and releasing flammable gases that rise above the surface. These gases then mix with oxygen from the air, and when they reach the right temperature, they ignite, creating the bright, dancing flames we see leaping from the logs. That's why we always start a fire with tinder and kindling, small, dry materials that heat up and burn quickly. Their job is to get hot enough to trigger pyrolysis in the larger, denser logs stacked above them. The bonfire is really a chain reaction in action. Heat creates gas, gas burns, and that burning releases even more heat, which keeps the cycle going and spreads the fire to new wood. The way you build your fire matters too. Stacking logs with enough space between them lets air flow in, ensuring that the gases have plenty of oxygen to burn efficiently and keep the fire strong. As long as there's a steady supply of wood and oxygen, the bonfire will keep roaring, consuming fuel and transforming it into heat, light, and mesmerizing flames. It's a simple yet powerful process, one that turns solid logs into a dazzling display of energy, warmth, and color, connecting us to a primal force that's both beautiful and essential. Have you ever wondered why a bonfire shines so brightly, lighting up the night and drawing everyone's attention? The heat and light of a bonfire come from combustion, a powerful chemical reaction that happens when wood meets oxygen and heat. This process is what transforms simple logs into a mesmerizing display of energy. As wood gas burns, the chemical bonds inside the wood break apart and new ones form, releasing a burst of energy. This energy escapes as both heat and light, which is why we feel warmth and see the flickering flames. The crackling sound you hear is also part of this reaction, as trapped gases and moisture escape from the wood. Tiny soot particles, heated to thousands of degrees, glow with intense colors, yellow, orange, and red. These glowing particles are what make the fire so visually stunning, creating the vibrant hues that dance in the flames and embers. The more soot there is, the brighter and more colorful the fire becomes. That's why a wood bonfire glows so much more than a clean blue gas flame, which has very little soot and gives off less visible light. The difference in color and brightness is all about what's burning and how. So every bonfire is like a glowing light show, powered by the hidden energy stored in wood. The flames not only warm us, but also create a magical atmosphere that brings people together. Next time you feel the warmth on your skin and see the golden glow lighting up faces, remember, it's all thanks to excited molecules, glowing soot, and the wonders of chemistry happening right before your eyes. Science makes the magic possible, turning ordinary wood into a brilliant, unforgettable spectacle. When you gather around a bonfire, you might think the flames are always just yellow and orange, but if you look closely, sometimes you'll spot streaks of blue, green, or even flashes of purple dancing in the firelight. These shifting colors aren't just for show. The color of a flame depends on both its temperature and the chemicals that are burning within it. For example, blue flames at the base of the fire mean it's burning especially hot and clean, with plenty of oxygen fueling the reaction. The familiar yellow and orange colors come from tiny particles of soot, glowing as they're heated by the fire. But there's more to the story. Trace minerals in the wood, like copper, sodium, or even potassium, can create sudden flashes of green, bright yellow, or even violet, depending on what's present in the logs or kindling. This is actually the same science that gives fireworks their brilliant colors. Each element glows with its own unique hue when it's heated up. So, when you see a bonfire with a rainbow of colors, you're witnessing a natural chemistry experiment in action. Every bonfire is like a living, breathing chemistry lab, painting a vivid picture of its ingredients right before your eyes. The flames reveal secrets about what's burning, changing color as different minerals and elements are consumed by the fire. If you ever notice a strange or unexpected color flickering in the flames, don't be alarmed. You're actually witnessing a live flame test, just like scientists use in the lab to identify elements. So next time you're sitting by the fire, remember, your campfire is more than just warmth and light. It's a glowing chemistry lab full of colorful surprises waiting to be discovered. Knowing the science behind a bonfire adds to its wonder. But with fire's power comes responsibility. Always build fires safely, keep water nearby, and never leave them unattended. When you're done, douse the fire and make sure it's out. Want to explore more? Try observing flame colors in a candle, or use safe color-changing fire packets. Science is everywhere, whether you're around a campfire, building a volcano, or gazing at the stars. Stay curious, ask questions, and keep exploring. Every bonfire is a chance to learn and wonder. So go out, explore safely, and keep the flame of curiosity burning bright.